Hi, this is Allison. I'm going to talk to you today about using Audacity to visualize and collect some data on bioacoustics recordings you might make for a field ecology project. In another video, I showed you how to use your smartphone and set it in certain ways to maximize good quality sound recording, and I made some suggestions for recording. Once you get your recordings, you're going to need to get them into a sound editing program so that you can visualize them and collect information that you can use for analysis. Audacity is a great program for that. It's free, and you can download a copy of it at audacityteam.org. The first thing you might need to do, though, is you might need to convert your file into something that's readable by Audacity. I use an iPhone, and so my iPhone records in M4A format, and it can't be read by Audacity. It has to be in either WAV or MP3 format. Because I'm recording in really high resolution, I need it to be actually in WAV format. So the first thing I need to do is to convert this file. So there is a default player on my computer, the VLC media player. And if I open that up and I actually select the upper left menu, there is this option here to convert files, okay? And so once I select convert, I can actually add a file here into the converter. I'm going to select this M4A file that I made, that I recorded. And then once you do that, you select this convert save button, and you'll be prompted to pick the kind of format you want to convert to. And for our purposes, we want to convert to audio CD format. You'll see there'll be an option to do MP3, but you want to have this converted to high resolution. You want to have it audio CD, which will convert it to WAV format. And then I'm going to find a place to save my new file. I'm actually going to save it in the same folder as my original recording. I'm just going to name it with the number 2. And I'm going to hit save. And then hit start. And what you'll see is I now have a WAV file that I can open up in Audacity. So if I go to Audacity and open up my file, this is what I see. I see a stereo track, so I see 2 files here, and they're in what we call waveform. They're being visualized in what we call waveform, and a lot of musicians use waveform to visualize and edit sound, but we actually want to use a different view to look at our sounds. We want to use spectrum view, and so waveform view, along the x-axis we're looking at time, and the y is basically volume. If you convert to spectrum view, what you're seeing now is along the y-axis, it's still time, but instead of volume, we're now looking at frequency, or the pitch of the sounds in the recording. And then instead of volume, what we see for volume is the darker pink smudges are the louder sounds. So I bet you that this is either me handling with some handling noise, or a car or something here. Oh, that's me moving. So you start to get good at knowing what sounds are human sounds and what aren't. But when I want to collect information on the sound, it's going to be easier if I can make this into what we call a mono track, so that I'm just looking at one of these tracks. These are identical. Basically, my microphone it doesn't make sense to have a stereo track. So the first thing I'm going to do is split the track. And I did that from this drop-down menu again. And then I make both of these tracks what we call mono. And then I get rid of this one. And I'm really happy with the range of view that I see here on my screen, because I'm capturing all the high frequency sounds as well as the low frequency sounds. If you're not seeing that, if it looks like sounds are being cut off, you may not have the settings here up as high as mine. And if you need to edit that, you can go into the edit menu and then into preferences. And in preferences, the default preferences are often 256 FFT size, and that just really has to do with how detailed you get these different marks look on the screen. I tend to go up to a higher resolution. And then the maximum frequency that you'll see along here is often set to something less than 10, because most music and voice is in about the 7 kilohertz or the 7,000 hertz range. Some bird sounds go up much higher than that, so I make this maximum frequency much larger, like 15,000 hertz. And I click OK. You can also, you might have seen, you can also visualize things in grayscale if that looks better to you. The next thing I do when I view a sound is I will zoom in, because I can see these smudges. I can see that there's sounds. I can say, okay, what's that? That looks like an interesting sound. And that is a Pacific wren. But I can't really see the sound. And so I like to zoom in to about 30-second chunks of the sound. Okay, this is a little bit zoomed in, but this is that same Pacific wren sound, and I can see so much more detail now that I've zoomed in. Let's play it again. Okay. You can also see the car noise down here. And so once you start to visualize your sound, you can get a lot of information here. And so you can look at where the sounds are happening that are the loudest. You can look at the overlap between sounds in different sort of frequency ranges. You may have environments that look like have this amount of low frequency noise. Again, this is a car. Okay. And you might compare what kinds of sounds you hear in these really loud environments and then in quiet environments. You might find that certain animals actually might be choosing certain environments because of their acoustic qualities. And so if I want to know something about volume and frequency in a portion of the spectrogram, I can select a small piece of it and say I want to know in this area, okay, of the recording, where was the sound, at what frequency was the sound the loudest? And I'm predicting it's somewhere here. And if I had to guess, I'm going to guess it's between 43 hertz and 14,000. It looks almost in the middle, so maybe somewhere around 7,000. But I can actually get a more concrete answer by plotting a spectrum. And what this has done is for that small selection of mine, it is looking at different ranges of frequency, okay, from low to high, and then mapping where the sound, mapping the volume. And so you can actually see right here, there are a couple peaks at, and you'll see that this little band here will show up once I put my cursor over a site. It will show me that at about 66,097 hertz, the volume was about -33. Okay, and that's one of the that's a peak in the volume right there, which is where we guessed a little bit. And so you can be mapping these sorts of different qualities about an environment from these sound recordings. You could take this information, put it into a spreadsheet, match it up with maybe a habitat survey from that same area, and then some landscape metrics, proximity to road, proximity to other sources of anthropogenic noise or human sound. And you can start to really address some questions in the field of bioacoustics this way.